Hello, we're looking in Geometry Part 1, Lesson 2-5 in your textbook. This is page 116. This particular lesson is talking about proving and using reasoning in your algebra and geometry. A proof, especially a two-column proof, if you'll read the page before this, it goes into detail about how to do this. But writing a two-column proof is simply, it gets its name because they're literally two columns. And in one column you have the statement, and in the other column you have the reason for that particular move. So you're going to do your math on the left side or do your statements on the left side, and then for every statement you make, you've got to have a mathematical reason for making that particular statement. And together that's like a proof. It's just like a lawyer would present his case to a judge. He would present what he says things to be true, and he would give reasons for everything that he does so that the judge or the jury would accept that. That's what we have to do when we do a two-column, or sometimes they're called a formal proof. Now, we are given that the measure of angle 1 is congruent to the measure of angle 3, and it's denoted here in the picture. And what we're asked to prove is that the measure of angle AEC is congruent to the measure of angle DEB. Well, those really overlap if you look carefully at what AEC is and DEB. They overlap. So just to kind of give you a thing, you always start with what you know. You proceed to what you need to prove. Okay? And so we're needing to prove that AEC is congruent to DAB. And then in your mind, you've got to get a plan. A lawyer doesn't go in the courtroom without pre-planning and being ready. If he does, he's not a good lawyer. So he goes into court with a plan. So here's the plan. Always start with the given evidence. And so that was that the measure of angle 1 is congruent to the measure of angle 3. And notice in the reason column, all I have to simply put is it was given, because that part was given to us. Okay? Now, in statement 2, what we're trying to do is, because they do overlap, they share angle 2 in common. So we have to make a statement that the measure of angle 2 is congruent to the measure of angle 2, which sounds like a silly statement, but mathematically we need to prove that they are equal to each other by reflexive property that simply says any angle is congruent to itself. Okay? So because in step 3, we're going to add the measure of angle 2 to both the original from statement 1, angle 1 and angle 3. We're adding the same thing to both of those. Okay? Now remember, that's called the addition property of equality there, because I'm adding the same thing to both sides. Now that I have statement 3 that says the measure of angle 1 and 2 together is equal to the measure of angle 2 and 3 together, then what I find out if I look carefully at my picture is that the measure of angle 1 and 2 is really AEC. Okay? And the measure of angle 2 and 3 together is really angle DEB. So that is simply just called angle addition postulate. If you add two smaller angles together, you're going to get the one bigger angle. And I did the same for both of those, so it's really the same reason. Now, because the measure of angle 1 and measure of angle 2 is equal to AEC, and the measure of angle 3 and the measure of angle 2 together is DEB, then I can simply say the measure, it's really kind of going from 3 to 5, that the measure of angle AEC, which represents 1 and 2 put together, is congruent to the measure of angle DEB, which is angle 2 and 3 put together. And I can say that because substitution property says if two things are equal, then you can substitute those values to get your final answer. And ultimately, just like your first step is always what's given, your final step here is always going to be what it was you were asked to prove. And that's called a two-column proof. These take practice. They don't come easy. The better you know your mathematical rules, like reflexive property or addition property or substitution, all those, the better you know those, the easier proofs are when you're doing that. But they do not come easy. But they force us to have to really have thought process put in to everything that we say within a particular math problem. All right? Best of luck on this.